This is the solutions video for Unit 1, Lesson 1, Foundations Unit and Math for Chemistry, the very first lesson. So, as the sheet says, it was assigned on the very first day of class. It should be done by Wednesday. You're not marked down if you don't have it done by then. Its absolute due date is the date of the first quiz, which is going to be Friday, September the 10th. But you really should, in order to keep up, that's what pace due date means, to keep pace, you should have it done by Wednesday. So what I'm going to do is I'm going to do some of the problems and leave the others for you to do. If you want help on the ones that I don't solve on this video, then you can come see me for tutoring, and that's when you can do those. Okay, so let's go. This follows the instruction video for this particular lesson. Everything is not necessarily in exactly the same order as the instruction video, but it's all the same material. Okay, so let's do this. So for the first one, we're going to cross the arrows. We're going to put 2 over 2. Again, 2 over 2 equals 1. 1 times anything just equals whatever that thing is. So 2/3 times 1 is 2/3. So all we're doing is we're changing the denominator, but we're not changing the value of 2/3. Okay, so the 3 comes over here, and it becomes 3 over 3. All right, then we can come down here. 2 times 2 is 4. 2 times 3 is 6. Plus 1 times 3 is 3. Over 2 times 3 is 6. And that's why we did that, is to get the common denominator. So 4 plus 3 equals 7 over 6. And that's the answer. You can leave this as an improper fraction. You do not have to change it to a mixed fraction. All right, same thing here. 3 times 3 is 9. 3 times 5 is 15. 1 times 5 is 5. 3 times 5 is 15. So you have a common denominator, and 9 minus 5 is 4 over 15. You don't change the denominator in these. Okay, so I'll leave these two for you to do on your own. All right, now we're going to multiply. Okay, so we just multiply straight across. So 2 times 4 is 8. 3 times 5 is 15. You can't reduce that. If you could have reduced it, you would have been able to reduce something here before you multiplied, but there was nothing that reduced here, so that's a simplest terms fraction. Okay, let's try this one. Okay, now this one does have some things we can reduce. So 2 goes into 2 one time, and it goes into 16 8 times. 9 and 15. 9 does not go into 15. However, they have a common factor, a number that goes into both of them. If they do, you want to find the largest number that would be true of. And in this case, it's 3. 3 goes into 9 3 times, and it goes into 15 5 times. So you cancel that and make it a 3. Cancel that and make it a 5. Okay, 5 times 1 is 5. 8 times 3 is 24, so that's the answer there. If you had not canceled before, you would have ended up with 30 over 144, and you would have found that if you reduce it down, you would reduce it to 5/24. But that's kind of complicated to reduce a big number like that down. So it's best to do your cancellations, your reduction, before you do the multiplication. Okay, so I'll leave these two for you to do. Okay, let's come down and do one of these. Okay. All right. So I'm going to do this one. And if you can do this one, you should be able to do this one or this one. All right. So this has got a whole number over a fraction. The parentheses means that that's a fraction. That's a whole number. So we're going to change this to 6 over 1. So that becomes a fraction. 3 over 4. Okay. So that's going to give you 6 over 1 times, and you flip this and make it 4 over 3. Okay, now we can cancel. 3 goes into 3 one time, and it goes into 6 2 times. So we have 2 times 4 equals 8, and 1 times 1 equals 1. You can put 8 over 1 if you want, but it's really just 8. Okay? All right, so you do the other two there. Come to me if you have questions about how to do those. All right, convert the following improper fractions to mixed fractions. Okay, the way you do that is just remember what a fraction is. It's a division problem. It's 2 divided into 7. So we're going to write it like that. Don't put any decimal 0, 0 here. Okay, what you want is a remainder. Okay, so 2 goes into 7 3 times. 3 times 2 is 6, and you're going to subtract that. 7 minus 6 is 1, and you're done with the division. So your answer is going to be, this number is going to be the whole number. That's how many times 2 went into 7. And then it's the remainder over this number, which is called the divisor. So it's 3 1/2. Okay, and that's the answer to that. You go ahead and do that one. All right, now we're going to go in the other direction. So we'll do this one. So remember from the video, what you did is you take those two numbers and you multiply them. Then you add that number, and then you put the whole thing you get from that over this denominator. So you kind of go around the world there like that. Okay, so it's going to be 5 times 2 plus 4, and that's all going to go over this 5. And order of operations is multiplication first and then addition. 5 times 2 is 10, plus 4 is 14, over 5 is going to be 14 over 5. Why is this important to do this? Well, to go in this direction up here, it's important because if you're taking a standardized test and they give you answers, multiple choice answers, they're not going to give you an answer as an improper fraction. They're going to give it to you as a mixed fraction. So you have to know how to do that conversion. Personally, I don't care. In my class, you can leave it like that. The reason you need to know how to do this is you can't do math with a mixed fraction. If you needed to multiply this number by something or add it to something, it would have to be in this form. Just one number over another, a numerator over denominator. You can't do math with a mixed fraction. You only go to a mixed fraction if you need to. As I say, if you're on a test and you need to give a final answer, then you do it in a mixed fraction. But you can only do math with either a proper or an improper fraction. Proper meaning that the top number, the numerator, is smaller than the bottom number, denominator. That's a proper fraction. Okay, now we're going to do some unit conversion problems. Okay, and this is going to be really one of the centerpieces of this class. You want to get good at these as quickly as possible. Okay, so these don't have anything to do with chemistry. So we're asking how many inches in 5.2 feet. Okay, so you have an equivalency here. So what you want to do right away is make your two conversion ratios or conversion factors. 12 inches for every 1 foot. I could put an equal sign or an or. I'm going to put an or because we want to choose one of these two. And it's going to be 1 foot for every 12 inches. Now I'm going to do something here that I didn't do in the instruction video. I'm going to come up here where I have some open space. I'm going to prove to you that either of these are true statements, okay? So I'm going to take this and I'm going to divide both sides by 12 inches. "12 inches over 12 inches, any number, any variable, anything over itself is simply 1. So you cross that out and put a 1. So 1 equals 1 foot over 12 inches. Now I'm going to do it a second time. This time I'm going to divide both sides by 1 foot. Again, anything over itself is going to equal 1, so I'm going to just put a 1 there. If 1 foot over 12 inches equals 1, and 12 inches over 1 foot equals 1, then it stands that these two have to equal each other. They both equal the same thing, which is 1, so that means they have to equal each other. So that means this truly is, I'll put an equal sign here, these two truly are equal to each other. Okay? Alright, but I usually write the or because the idea is you're going to make a decision which of these you're going to use. Okay, so what you start off by doing is identify what is the question asking for. What does it want to know at the end? What it wants to know is inches. How many inches? So I'm going to come way over here on the right. I'm about to set up an equation, create an equation, and I'm going to write some number of inches. So that's where our final answer is going to go. What does it give us to start with? It gives us 5.2 feet. So I'm going to come way over here, and sometimes you want to leave a lot of space because you don't know how many conversions you're going to need. You're going to get to problems where we have needed quite a few conversions between what we start with and what we end with. So I'm going to come way over here and say 5.2 feet. Now I'm going to go ahead and draw a box. Some people draw parentheses. I like to just draw a box with a ratio, so this is something over something. And what we're going to do is pick one of these two conversion factors to go in that box. Remember, they're both true statements. These are both true, but only one of them is appropriate to go in this box. We want feet to cancel out and inches to appear on the top in our final answer. So which one of these two does that? Well, it's this one. So we're going to come write that over here. Okay. So what we have is feet on the top canceling with feet on the bottom. The only unit left, the last man standing, is this one, and so that's the unit that would be in your answer, and that's what you want. That's what you said you were looking for. So you take care of the units first, and then you go back and do the math. So now what we have is 5.2 times 12 divided by 1, which of course you don't really have to do the divided by 1, and that gives you 62.4. Okay. All right, that's how you do these. Let's do another one. This one requires two conversions. So that's a little trickier, and I didn't show you how to do those in the video, so you're going to learn. All right, so we start off the same way. Well, here, I tell you what, we're actually going to start off by writing our conversion factors. So here's an equivalency. So one of our equivalencies is 12 inches for every 1 foot, or 1 foot for every 12 inches. Okay, that's this one. Now we have this one as well. 3 feet for every 1 yard, or 1 yard for every 3 feet. Okay, so we're going to need two conversions. Why? Because it's asking how many inches are in 4.1 yards. Well, neither of these gives us a relationship between inches and yards. Here we have we don't have that here. So what we have to do is go from, we were starting with yards. In other words, that's what we were given to start with. We want to end up with inches. So we need to go from yards to feet. This equivalency gives us that relationship. And then we have to go from feet to inches. This equivalency gives us that. So what you're going to do now, I'm going to draw a line here to separate these two. What are we looking for? Again, we're looking for inches. And what are we starting with? 4.1 yards. So I'm going to come way over here to the edge of the paper because you're going to need the space. And we're going to multiply that by two conversions. Okay, so we're going to need two conversions to get there because just neither one of these will do it by itself. So how do you know which ones to use? You got 1, 2, 3, 4 choices. Okay. Well, you start with yards, you're going to end up with inches. So yards has to cancel out. So right here you have yards up on the top. So you need yards on the bottom. There's only one of these that has yards on the bottom. And it's this one. So we're going to write 3 feet over 1 yard. 3 feet for every 1 yard. Okay? All right, now what about the second conversion? Well, there's two ways you can look at it. We need inches in our final answer. That means we need inches on the top right here. There's only one of these four that has that. Or another way you could look at it is similar to what we did with yards. We have feet right here, but feet doesn't appear in our final answer, so it has to cancel out. So we need the one with feet on the bottom down here, so these two will cancel. And this one, again, it's the same one I just pointed to, is the only one that does that. Okay, so we're going to go ahead and put that here, that there's 12 inches for every 1 foot. And now we cancel. Yards cancels with yards. Feet cancels with feet. Remember, you're canceling just like you cancel a variable in algebra class or a number in math class as well. Okay? And the only thing we have left here that wasn't canceled is inches. That's the last man standing, and that therefore is the unit in your final answer, which is what we want. The question's asking us how many inches. Now that you've got the units set up, you can do the math. You multiply everything on top and you divide by everything on bottom. So 4.1 times 3 times 12 divided by 1 will give you the answer. Now, of course, as you can see here, you don't really need to divide by 1. That's not going to change the number. But in many problems, these will not be 1. So you should just understand how that's done. So we said that's going to be 4.1 times 3 times 12, and that gives us 147.6 inches. Okay. All right. Okay, I'm going to leave C for you to do. That is, again, 2 conversions. You need to get from inches to miles. You have a conversion from inches to feet and from feet to miles. So you're going to do that one exactly the same way, but you got to figure out, first write out all of your possible conversion ratios or conversion factors, and then go ahead and set up your equation. It's asking for inches. That's going to go over here. It gives you 1 mile. That's going to go over here. Miles abbreviated MI. And then you're going to need 2 boxes, just like you did here. And go ahead and set that up. Okay? So that one's for you to do. All right. How many centimeters in 7.8 meters? Well, let's see. Okay, this is just a single conversion because we do have a conversion from centimeters to meters. I give it to you here, but there's a table you'll see later in this assignment where you could have gotten that. Okay. All right. So what do? We write our conversion factors here. There's 100 centimeters for every 1 meter, or that's equal to 1 meter for every 100 centimeters. All right. So what are we trying to find? We're trying to find centimeters, and we use the abbreviation cm. I like to draw a line because that's where my final answer is going to go. And then we're starting off with 7.8 meters, m. And it's only 1 conversion, so I'm just going to put 1 box there. Okay, so we need meters to go away because it's not in our final answer, and we need centimeters to show up. So which of these 2 goes in there to make that happen? Well, we need meters on the bottom to cancel with meters on the top here, so we're going to use this one. Cancel bottom, cancel top. Last man standing is centimeters. So it's 7.8 times 100 divided by 1 is 780 centimeters. Okay? All right. Here's another one, single conversion from micrometers. That's 1,000,000 micrometers equals 1 meter. If you want to use scientific notation or just use an exponent, it's 10 to the 6th micrometers. That would be 10. So if you want, you can express that as 10 to the 6th meters. That's micrometers. Or if you just want to deal with that number like that, you can do that. Okay? Okay, I'm going to leave that one for you to do. All right. And how many grams is 785 milligrams? There's 1 gram equals 1,000 milligrams. And so you can do that one. That's just a single conversion problem. Okay? All right, now we're going to move on to scientific notation. Convert the following decimal numbers to scientific notation. So what you do is you start off, if there's a comma here, you get rid of it. And then you put the decimal point where it would be. You don't really write a decimal point there normally, but that's where the decimal would be, if there were a decimal there. So what you need to do is make this a number between 1 and 9.99. So we're going to move it over right there. That's 2,340. That's too big. That's 234. That's too big. That's 23.4. That's too big. There we go. 2.34 is a number between 1 and 9.99. So I'm going to write that number down here. and it's times 10. And the original number, 23,400, is greater than 1, so it's going to be a positive exponent, and we had to move that decimal 1, 2, 3, 4. 4 loop-de-loops there, so 10 to the 4th. So that's 2.34 times 10 to the 4th. All right, let's do this one. So we do see a decimal here, and we need to make this a number between 1 and 9.99. So we're going to go 1, 2, 3, 4 right there. So that's 3.2. And again, we had to move it 4 places over, but this number, this original number, is less than 1. It's a positive number, but it's a positive number between 0 and 1. So it's less than 1. So that means it's going to be a negative exponent. Again, negative exponent does not mean a negative number. It means a positive number between 0 and 1. And that's what we have. If it were a negative number, you'd put a minus sign out there. That would be a negative number. But a negative sign there just means it's you move the decimal to be a number between 0 and 1. Okay? All right. Let's keep going. Now we're going to convert these to a decimal number. So what you do is you write the coefficient by itself down here. And you see that 10 to the third is going to make it a bigger number than 4.2. 10 to the third is 1,000, so you're multiplying by 1,000. So what you got to do is move the decimal 3 places and just use your common sense. If it's going to be a bigger number than 4.2, then you're going to have to move the decimal to the right. 1, 2, 3 places. Okay, and there's the egg carton right there, so you got to put the eggs inside. There's the eggs in the egg carton. Okay, and don't leave your final answer like this. Go ahead and write 4,200. You don't have to write the decimal point after that. You shouldn't. And that's it, okay? You want to put a comma there, you can, but you don't have to. All right? This one, same thing. We're going to write the coefficient down here by itself. And this is 3, and this is going to be a number smaller. It's going to be a number less than 1. That means we need to move the decimal to the left here. So it's going to be 1, 2, 3. There's the decimal. Fill the egg carton with the eggs right there, and then write the final answer. You should put a leading 0 in front of the decimal, and then it's 0.00983. Okay? All right, so these others over here that I'm not doing, those are for you to do, for you to practice on. We can talk about them in class, or you can ask me during tutoring hours. Okay, here we go. Now we're going to do some multiplications here. Now, there's a concept called significant figures, which you're going to learn in a couple of days. I'm not going to get into that here. I'm just going to kind of randomly cut the number off. But when you learn about significant figures, well, if I can teach a little bit of it here, I will. All right. So, first thing we got to do is multiply 5.2 times 2.8. Okay, and that's going to give us 14.56. All right. Yeah, I'm not going to do the significant figures now. That's a separate lesson. Let's do that separately. Okay, so you multiply this times this, and then you add this plus this. So that's going to be, let me just write that a little bit lower down here, 14.56 times 10, and 5 minus 3 is 2. Okay. Now, we said in the instruction video that this has to be a number, we've said it many times, that this has to be a number between 1 and 9.99. So I'm going to move this over here to make it a smaller number, a number between 1 and 9.99. Since I made this number smaller, I've got to make this number bigger. So this, and how much bigger do you make this number? Well, how many spaces did you move this? You moved this over 1 space, so you're going to make this 1 digit bigger. In other words, what you did here is you took 14.56 and divided it by 10 to get 1.456. So what you have to do is take 10 to the second and multiply it by 10 to get 10 to the third. Every time you increase an exponent by 1, it's like multiplying by 10. So divide by 10, multiply by 10. So these two numbers are the same value. But this one has the appropriate coefficient that's a number between 1 and 9.99. Okay, let's go ahead and do this one. 0.2 times 6.1, and that gives us 1.22. So you can see right away we have a number between 1 and 9.99. We don't need to make any decimal adjustment. So let's just do what our exponent is. Negative 9 plus 3 is going to be negative 6. Okay, and that's the answer there. All right, you go ahead and do the last two. Okay, now we have some division. And division, the rule is you divide the coefficients and you subtract the exponents, okay? So 8.4 divided by 2.7 is going to give us 3.1. And negative, whoops, wrong place, sorry about that. 3.1. Okay, and 5 minus 2 is 3. Okay. All right. Let's go ahead and do this one that I almost did. Okay, so 4.1. By the way, this is a number between 1 and 9.9, so you don't need to adjust the decimal. Okay, so 4.1, doing this one right now, divided by 2.9, and it gives us 1.4. So that again is a number between 1 and 9.9. Times 10. Now you've got to be very careful with divisions and not flub up the minus signs. So negative 5, I would actually write it out until you're really good. Minus 2 equals negative 7. So that's going to be to the negative 7. Okay? Okay, let's do this one. This one's going to be a little tricky here. 3.2 divided by 6.4. Okay, well I can see that that's going to be 0.5. That's exactly half of 6.4. So that's, now this is tricky and a lot of students flub this up. It's negative 2 minus negative 7. That becomes negative 2 plus 7. And sometimes I always think it's easier to flip it around and make it 7 minus 2, which is 5, positive 5. Okay. All right. So now we have a number that's not between 1 and 10, or 1 and 9.99. So we're going to move it over here to make it 5. That'll be a number between 1 and 9.99. So we made this number bigger. We went from 0.5 to 5. And you don't have to write 0.0 or anything. So we multiplied this by 10 to get this. So we've got to reduce this. If this one gets bigger, this one gets smaller. And that's the answer. You move this over one space to make this bigger. You multiplied this by 10. You divided this by 10. All right. Okay, I'm going to leave the rest for you to do. Okay, that was 3 out of the 6. So you do the rest of them. Okay. Here is a nice table that shows you all the prefixes. I'm going to just ask you some questions about those. In a later lesson, we'll talk about how do you convert from one of these to another one. In other words, just how do you get, if something was given in milligrams and you wanted it in nanograms, how would you do that? So we'll talk about that in a later lesson. But right now, you should know these names. You should know these abbreviations. And again, you don't necessarily memorize them. You just kind of learn them by doing. And you should know what the exponent is. In other words, instead of writing milli with an M, you would write 10 to the minus 3. Instead of writing micro with mu, the Greek letter mu, you'd write 10 to the minus 6. This is the actual decimal representation, but the whole idea of, exponents like this, 10 to the power, is to not have to write these big long numbers. Okay, so the ones you're going to use a lot or fairly often, are giga, mega, and kilo. You're never going to use those two. You're probably never going to use this, but you will use centi, milli, micro, and nano. Pico is really, really small, so you almost never use that. The thing is, when you get from 10 to the minus 12, 10 to the minus 15, 10 to the minus 18, they have names like this, but nobody ever uses the names. They just say 10 to the minus 15th or 10 to the minus 18th. They don't call it anything. They don't give it a name anymore because it's so rarely used. Okay, so the ones that I put checks by, those are the ones that you'll use, fairly often in this class. Some of them almost every day. So what's this asking us for? It's saying use the table below to express, and actually the table was below, it's now above, the following scientific notation. Okay, so milli. So milli is 10 to the minus 3. Okay, so you replace that m with this, but you still, the unit here is still grams. So it's 320 times 10 to the minus 3. Okay, now, remember we need to adjust our decimal. 1, 2 to get it to be 3.2, so that's 3.2. We made this number smaller going from here to there, so we've got to make this number bigger by 2. Now be careful on this. Times 10 to the, what is 2 positions bigger than negative 3? Is it negative 1 or negative 5? It's negative 1. You're going in the positive direction. So again, we made this number smaller going from this to this, so we need to make, and it was 2 positions that we moved the decimal over. So we have to make this by 2 positions bigger to offset that. And bigger from a negative number is going in the positive direction, from negative 3 to negative 1. So there's your answer. Okay, 52. Come over here. It's centimeters, cm. So you come over here. Centimeters is 10 to the negative 2nd. Okay, and there's the decimal. We got to move it over in between the 5 and the 2 to get a number between 1 and 9.9. So we made this number smaller. We've got to make this number bigger. So that's going to equal 5.2 times 10 to the minus 1. Okay, that's 1 position bigger is 10 to the minus 1. Okay, 720 picometers. So there's pico. It's a really little one, 10 to the minus 12. That's minus 12. Let me try that again. To the minus 12. Okay? So the decimals here, you're going to move it over 2 places to create a number between 1 and 9.9. Times 10 to the, so we made this number smaller. Oops, I wrote 7.9. We made this number smaller. So we have to make, let's say that again. We made this number smaller, 720 to 7.2. So we have to make this number 2 positions bigger. That means you're going in the positive direction. So it's 10 to the minus 10. Okay? So you've seen how these work. Okay? So I'm going to leave the last 4 for you to do. Come see me, or we'll talk about some of these in class. But come see me if you have questions on the rest. All right? So hope you enjoyed your first day in class. And we'll be moving at a good pace. So try to keep up with these assignments. Have a good day.